Let's talk about solubility of substances in water and perhaps make sense of solutions in water using the state of Texas STAAR chemistry tables that are on the back of the periodic table. First, some facts. Solids, liquids, and gases can dissolve in water, and different substances dissolve in different ways. What substances are the most soluble? Well, ionic substances are the most soluble because water is a polar molecule and the plus and minus end of water attracts the minus and plus ions in a salt or an acid or a base. Polar molecular substances are also soluble. They tend to be quite soluble in water. I'll give you the example of hydrogen chloride gas, HCl, or ammonia, NH3, or a compound like ethanol that is not ionic but has an OH at the end. Now, molecular nonpolar generally are not soluble because there's no attraction particular between the polar molecule and the water molecule. And the water molecules, because they're polar, the plus end of one hangs on to the minus end of the other very much. And so there's really not enough energy to break through that hydrogen, oxygen, hydrogen connection there. What is the enthalpy effect of dissolving? Some require energy to dissolve, so that heating them makes them dissolve better. Some give off energy when they dissolve. What affects the rate of dissolving? This is something that you'll find on your worksheet. Higher temperature speeds up the dissolving of solids because the water molecules are vibrating in their liquid form. They're vibrating faster, and so they can hit the solid particles harder and break them up. Endothermic dissolving processes are really very much affected by higher temperatures because it requires energy to get the solid to break up. Adding heat then makes a larger amount of the substance dissolve. And cooling off reduces the amount of that substance that can dissolve. Exothermic dissolving, however, tends to just proceed very well, and higher temperature will perhaps not do much. Certainly not much in terms of dissolving more or faster. And in fact, if it's an exothermic dissolving, you heat the temperature up too high, you won't be able to put as much in. What about grinding the solid down into smaller particles? Will that affect the rate of dissolving? Well, yes, it will, because there's better interaction between the water and the smaller solid particles. They've already broken up to a certain extent, so the water doesn't have to work quite as hard. What about stirring the solid vigorously? That puts the solid particles into contact with the water more, and so that would increase the rate of dissolving. What about adding more solvent? Well, if you double the amount of water, you should double the rate of dissolving, particularly if you keep stirring it. What about adding more solute? Well, you just remember, you've got this glass of iced tea that's already sweet, maybe has as much sugar as it'll hold. If you add more sugar to it, even if you stir vigorously, you won't get any more to dissolve. So that would not affect the rate of dissolving. What about gases? What does this chart tell you about the solubility of gases in water as the temperature increases going from left to right on this diagram? Well, sure, it tells you that the gases, when they get hot, won't dissolve as well. So be careful. Leave the air conditioning on your aquarium when you go on vacation, especially if it's hot outside, or else your fish are going to die. Why do some substances not dissolve well in water? Oxygen being a good example. Well, water does not have unlimited kinetic energy. Suppose that energy is less than is needed to break up all of the solid crystal. Well, it won't dissolve quite as well, will it? An equilibrium will establish with some amount in solution, and maybe it's very little. All the rest of the solid will fall to the bottom of the beaker or the other container. Remember lead iodide, the yellow substance? The lead ions ran into the iodide ions, and they wouldn't let go. The water didn't have enough energy to break up that lead iodide crystal. Now let's look at your STAAR reference guide. You see something that looks like this. There are two tables in the middle of the back of your periodic table. The top table tells you all the compounds that are soluble in water, and the few exceptions. For instance, we say that bromides are generally soluble in water. However, silver bromide, lead 2 bromide, and silver 1 bromide are not. And that's the same thing with the other halides, chloride and iodide. With the sulfate, generally sulfates are soluble in water, but compounds of strontium, barium, lead, and mercury 1 are not soluble. So the exceptions on the top table are those that aren't soluble. Everything else is. So if someone tells you magnesium cyanide, yeah, it's soluble in water because all cyanide compounds are, and all ammonium compounds are. That's that one cation that tends to always be soluble no matter what it's combined with. So if you're asked if barium acetate is soluble, you would see that the acetate compounds, right up here, are always soluble, and you would say, yes, it is. Your answer would be yes. Or if you want to know if ammonium sulfate is soluble in water, you look at the table and see that the ammonium ion here is in the top table. So your answer would be yes, ammonium sulfate is soluble in water. Now if the test asked if silver iodide is soluble in water, you look at the table and see the rule, yes, iodides are soluble, but it also says that silver, in terms of iodide, chloride, and bromide, that's one of the exceptions. Your answer would be no, it's not soluble in water. The bottom table, the second table, that's below the first, tells you compounds that are almost never soluble in water. And so we look at that and we see carbonates, phosphates, chromates, dichromates, hydroxides, and sulfides. Suppose the test asks you if sodium carbonate dissolves in water. Well, you see that carbonates are generally not soluble, but compounds of ammonium and the alkali metals are soluble. The exceptions on this table are the ones that are soluble. So, sodium carbonate is an exception and does dissolve like all other sodium compounds. So what would your answer be? Yes. Suppose it asks you if magnesium hydroxide dissolves in water. See that hydroxides are generally not soluble, insoluble, and magnesium is not one of the exceptions, although the related ions, barium, strontium, and calcium are. Magnesium hydroxide is not on that list of exceptions. Therefore, your answer would be no.